In the beginning, there was nothing. No matter, no energy, no space, no time. Not darkness, not even the absence of light. Just nothing. Then, 13.8 billion years ago, the universe exploded into existence. The Big Bang wasn't an explosion in space, it was an explosion of space itself. In the first fraction of a second, the universe inflated from smaller than an atom to larger than a galaxy. It was unimaginably hot, so hot that matter as we know it couldn't exist. Only pure energy in the form of radiation and exotic particles. As the universe expanded, it cooled. Within the first second, quarks combined into protons and neutrons. Within the first 3 minutes, protons and neutrons fused into the first atomic nuclei, hydrogen and helium, with traces of lithium. But it was still too hot for atoms to form. The universe was opaque, a dense fog of particles and light. For 380,000 years, it cooled further. Then, suddenly, it became transparent. Electrons bonded with nuclei to form the first atoms. Light could travel freely for the first time. This light, stretched by the expansion of space over billions of years, is what we detect today as the cosmic microwave background radiation, the afterglow of the Big Bang, still visible in every direction we look. But the early universe wasn't perfectly smooth. Tiny quantum fluctuations during inflation created regions slightly denser than average. Gravity amplified these differences. Denser regions attracted more matter. Over millions of years, these density fluctuations grew into vast structures, the first stars and galaxies. The first stars formed about 100 million years after the Big Bang. They were massive, hundreds of times the mass of our sun, and short-lived, burning through their fuel in just a few million years before exploding as supernovae. These explosions created the first heavy elements: carbon, nitrogen, oxygen, iron, the building blocks of planets and life. Galaxies formed as stars clustered together, drawn by dark matter halos we still don't fully understand. Our galaxy, the Milky Way, began forming about 13.6 billion years ago, just 200 million years after the Big Bang. It started as a small protogalaxy and grew by merging with other galaxies, a process that continues today. About 9 billion years after the Big Bang, in a spiral arm of the Milky Way, a cloud of gas and dust began collapsing. At its center, temperatures and pressures rose until nuclear fusion ignited. A star was born. We call it the Sun. Around it, the remaining disk of material clumped together through collisions and gravity, forming planets. This happened 4.6 billion years ago. Earth was one of these planets, forming in the habitable zone where liquid water could exist. For its first 500 million years, Earth was bombarded by asteroids and comets, which brought water and organic molecules. Around 4 billion years ago, the bombardment eased. Oceans formed. Chemistry became complex. Then, about 3.8 billion years ago, chemistry crossed a threshold. Molecules began replicating themselves. Life began. Single-celled organisms evolved, then multicellular life, then complex ecosystems. Life didn't just exist on Earth, it transformed it. Photosynthetic bacteria filled the atmosphere with oxygen, rusting the planet's surface and making complex life possible. For most of Earth's history, life was simple: bacteria, algae, simple animals. Then, 540 million years ago, the Cambrian explosion saw complex animals diversify rapidly. Fish, then amphibians, then reptiles, then dinosaurs ruled the Earth for 165 million years. An asteroid impact 66 million years ago ended the age of dinosaurs and opened ecological niches for mammals. Primates evolved in trees. About 6 million years ago, our lineage split from chimpanzees. We became upright walkers with larger brains. We invented language, tools, culture. Homo sapiens appeared about 300,000 years ago. For most of that time, we were just another animal, hunter-gatherers in small bands. Then, 12,000 years ago, we invented agriculture and civilization began. Writing, cities, empires, science, technology, all in the last 5,000 years, the blink of an eye in cosmic time. And now, just decades ago, we developed the technology to look back in time. Telescopes detect light from galaxies so distant it took billions of years to reach us. We're seeing the universe as it was when it was young. We've measured the age of the universe, mapped the distribution of galaxies, and discovered that the expansion is accelerating, driven by mysterious dark energy. The universe is 13.8 billion years old. It's about 93 billion light-years across, larger than you'd expect from its age, because space itself has been expanding faster than light can travel through it. It contains at least 200 billion galaxies, each with hundreds of billions of stars. Earth is one planet around one star in one galaxy among billions. Yet here we are, atoms forged in the cores of ancient stars, arranged in patterns complex enough to contemplate their own origin. The universe has spent 13.8 billion years becoming aware of itself. You are not in the universe. You are the universe, locally organized into a form capable of asking, where did I come from? And the answer is, from nothing, through everything, to here. From quantum foam to galaxies, to planets, to life, to consciousness. The universe didn't just create you, it became you. Every atom in your body was once inside a star. You are literally made of stardust, and when you look up at the night sky, you're looking at your ancestral home. The story isn't over. The universe is still expanding, still evolving. In 1 trillion years, the galaxies will be so far apart that future astronomers won't be able to see them. In countless trillions more, the last stars will die. But that's unimaginably far in the future. For now, the universe is young, and we're here to witness it.